A wonderful weekend. So I want to begin by just giving you guys a little bit of a pump up speech. So we're about 5-6 weeks away from the exam. Okay. So obviously, perhaps a good goal for you guys is to be successful in the exam, right? So when you get to my age, when you're a senior fella, and you're sort of wondering, oh, what is it I want to do with my life? What do I want to pursue? You don't really know. You're like, what's a good goal to have? How do you set goals? A really good way to set goals, right, is to think of your life. Okay, for you guys, it's in 7 weeks' time. Once exams are finished. Okay, think of your life in 7 weeks' time. I'm thinking of my life in 5 years' time, and I'm thinking of what is the worst possible scenario my life could be in? What's the worst it could possibly be? Okay, so for me it's like, you know, I lost my job, you know, got addicted to drugs, got not allowed to see my family. You know, I can name all these things in which my life would be really, really, really horrible. Okay?
You know what this
and so then, then the opposite. Then what I want to pursue then is the exact opposite of that. This is what I don't want, and so what I do want is the opposite of, well, that's hell. I don't want hell. I want what is right, what is good, what is true. Okay, so that means what do I want? I want to have a strong, healthy relationship with my family. I want to be successful in my job. I want to be healthy. Okay, I don't want to be addicted to drugs or, you know, an alcoholic or anything like that. So I've got this sort of rough idea of what it is that I want. Okay, so for you guys, 7 weeks time. Okay, what's the worst case scenario? Didn't do any exam revision. Maybe you slept in your exams, didn't rock up to them, or you just performed really poorly. Okay, because the reason you have this sort of goal in mind is from now on, you know, you've got 6 weeks. What's that? 42 nights. Okay, every night you have the opportunity to tilt yourself in one direction or the other. Am I going to tilt myself towards hell? Or am I going to tilt myself towards the outcome that I desire? Okay? And so, you know, like it comes down to every decision I make. All right, so Friday night, went out to the pub, had a few beers, you know. Oh, let's have another round. Okay, which direction does that lead me towards? Is it the life that I want with my family, where I'm serving my family? Or is it the life that's sort of self-serving and about the individual, the life that I don't desire? And so every action you guys take between now and your exam is going to lead you towards the result you want or the result you don't want. Okay, so that's it. So let's talk about this exam. I'm going to flick through, and if one person wants to do a question, we will do it. Okay. On the first page here, we have some differentiation. This is how all of the exams start. Open up, there's some differentiation. Every now and then they have an indefinite integral. Okay, that's just sort of a warm up, get the brain juices flowing. You should never get any of these wrong. Okay, you should be really good at differentiation so that you get all of them right all the time. All right. Notice also how it says there is no need to simplify. Okay, so that just means apply the rule and smash it together. You don't need to make it more simple. Would anyone like to go through any of these? Very good, let's proceed. In question 2, we have a probability distribution. All right, would anyone like to go through any parts of question 2? Yep, so any part in particular? So if we talk about part A, explain why A plus B is 0.9. Well, that's because for a valid probability distribution, the sum of all probabilities is 1. Part B, given that the mean is 0, write down another equation for A and B. All right. Well, the mean is the sum of each event times its probability. So if this is the distribution, okay, -1, 0, 2, and we have A, B, and 0.1, then the mean is -1 times A plus 0 times B plus 2 times 0.1. Okay, it's each event times the probability of that event occurring. And we know the sum of each event times the probability of each event. The mean, we're told, is 0. Okay? So we have another equation here involving, well, it's just going to be A, isn't it? We're going to have minus A, that's 0, plus 0.2 is 0, and so we'll get A is 0.2. Okay, that's what we're getting from there. Yep, using the equation, find the values of A and B. We've got the value of A, and then we can use, so we've got A is 0.2, and in part A, we have the equation A plus B is 0.9. So we have 0.2 plus B is 0.9. We've got B is 0.7. All right, and then the last part, calculate the standard deviation. So here I would just use a formula for standard deviation. I think it's written on our formula sheet. Standard deviation of a probability distribution. Okay, it's the square root of each value, take the mean squared times the probability. So we've only got 3, which is pretty good for us. And I'm going to write the probabilities here to help us, 0.2 and 0.7. And I'm going to do the calculation right here. Okay, so it's this formula here, sort of in the middle on the left. Standard deviation is the square root of the sum of each value, take the mean. So -1, take the mean is 0. Each value, take the mean squared times the probability. Okay? Value, take the mean squared times the probability of that event. Plus, okay? The next one, take the mean squared times the probability of that event. And then the third event, take the mean squared times the probability of that event. Okay? With the square root, so it's just a matter of calculating that. Now, another way we could do that, or to verify our answer, is to put this in our calculator in statistics, row 1, row 2, column 1, column 2, and then get it to calculate the standard deviation for us. Okay? Excellent. Okay, question 3A. Everyone okay with that? So let's go through 3A. We have 5 ln2 plus half ln16, take ln8. I want you to write it in the form lnk. It means bring it all into one natural logarithm. Okay, so I'd be looking at it like this. Well, 5 ln2 is ln2 to the power of 5. So that's ln of 32. Yep. This is ln of 16 to the half, which is, the square root of 16, so that's plus ln of 4. And then we have, take ln of 8 just hanging out. We know if we have that, we can write it as ln of 4 times 32. All right, take ln of 8. So that's going to be 128. And then when we have take, it's divide, isn't it? So what's 128 divided by 8? Divide both by 2. 16, is it? Okay, so this we can simplify to be ln of 16. Alright? Part B, solve the equation ln 16 plus 2 ln x equals 0. Okay, 4x is greater than 0. So here we will, there's a couple of things we could do. Thinking of a couple of routes we could take. So you could move the ln 16 over the other side. So you have 2 ln x is minus ln 16. Divide both sides by 2. So we'll have ln x is minus half ln 16. And we know that that half you can write as a power, which is minus ln of 4. So we've got ln x is minus ln of 4. Okay.
When the 2 go as the square root of 8, like the
You could write it as x squared, that's correct, yep, we could. So we could have x squared is ln of 16. Okay, so here what we can do, we've got this sort of negative. So I'm just thinking what's going to be the best way for us to deal with that to solve for x. So if we have ln x is negative ln 4. Okay, if we're okay with that so far, that's it, that's our statement. And you're thinking we can put e to the power of both sides. E to the ln x will be x, but e to the negative ln 4 is not doesn't just simplify to 4. Okay? But nonetheless, we could think about it like this. Let's put e to the power of both sides. So we've got e to the ln x equals e to the minus ln 4. So this side is x. We've solved for x. And e to the minus ln 4. Yeah, like we could leave it like that. Does it say solve the equation exactly? No, so I think that's probably a suitable solution, and it is 3 marks. Okay, so like that's fine. E to the negative ln 4. How could we process it a bit? Because they will sometimes they will get you to manipulate or show that it's this. We could write that as e to the minus 1 times ln 4. Now it's not plus, so here we go. That negative, you could write it like this: ln 4 to the minus 1, which is e to the ln of 1 on 4, which is 1 on 4. There we go. That's a much tidier answer. Okay, so let's break that down. That negative, okay, that's negative 1. Okay, that can also become a power. So you have ln 4 to the negative 1, and then we've got an e to the ln of x. It just simplifies to the x. 4 to the minus 1 is 1 and 3. All right. Question 4 was a first principles problem. Okay. So just like conscious of time, I think I might rush over that one, and if you want to go through that, let me know. I definitely want to talk about question 5, because I saw going around, I saw a few people had sort of skipped over it. So if I bring it up, we can talk about the graphical here. Okay. Points A and B lie on the curve. Point A is the only point of inflection. Which of the following statements is true? Okay. So here it's talking about the slope. All right, it's talking about the slope. It's saying G dash. So we've got G dash of 1 is less than G dash of 2. G dash of 1 is equal to G dash of 2. Or G dash of 1 is greater than G dash of 2. So let's look at this, and we're going, what can we say about the slope at point A and point B? Okay, so I'd just by looking at them, you can tell that it's steeper at A than it is at B. Okay, just by looking at it. It's got this, if you were walking uphill, that's going to be the steepest part, that's going to be less steep. So the true statement then is that the slope at 1 is larger than the slope at 2. Okay, it's steeper at that point. So it's the third statement is the correct one. What's the justification? Okay, so the justification, you could write it's from the graph it's steeper, okay, but I don't think that would be sufficient. All right, what we should remember from calculus is that when we have a function, okay, a point of inflection is a local max or minimum on the derivative function. Okay, so if we have a point of inflection, that means it corresponds with this is the slope function, the slope function being a maximum. That's when it has its maximum slope at a point of inflection. Okay, always the case. So point of that, we have a point of inflection at x is 1, so that means the function is steepest when x is 1. Okay, so what's our justification? We would write the steepest slope occurs at point of inflection, which is at x is 1. Okay, now we're talking about the second derivative. Okay, which of the following statements is true for the second derivative? Now, I don't think you're not given the function here, so this isn't one that you can graph and try and figure it out. We've got to think about the concavity of it. Okay, so we have this function. Now, the point of inflection is here. Okay, and then this point here is when x is 2. So this is a point of inflection. Now, what's the relationship between the second derivative and a point of inflection? Point of inflection occurs when the second derivative equals 0. Okay? Which means at this point, the second derivative is 0. Okay? How about at this point? At this point, the function is concave down. It's concave down, which means the second derivative at this point is negative. Okay? If it's concave up, the second derivative is positive. If it's concave down, the second derivative is negative. And we know at this point, so g dash dash of 1 is 0, and we know that g dash dash of 2 is going to be negative. We don't know what value it's going to take, but we know it's going to be negative. And so we have enough information to answer the question. Which of the following statements is true? It's the third one again. That the second derivative at 1 is larger than the second derivative at 2.
So not equal to.
Oh, sorry, it's asking if it equals 0, isn't it? Sorry, it's the second statement. G dash of 1 is equal to 0. Okay. So I've answered both part C and D here. Okay. So part B, G dash of 1 equals 0. What's the justification? Point of inflection occurs when the second derivative equals 0. Okay, that's the justification. Then for part C, which of the following statements is true? Okay, and the answer is, well, the second derivative is negative, so it's the first statement. The second derivative is less than 0 because a function is, if the function is concave down, then the second derivative is negative. Okay, and that's going to be our justification that we scribble in there. So I'm thinking, what about, like I'm just looking through this, what about we just go through the first booklet this lesson, and then tomorrow we can go through maybe the second half of the booklet and talk about some of those, just to give you guys a bit of opportunity to ask some questions. So with question 6, this is one you've seen pop up in practice tests and so forth. Does anyone want to go through question 6? Yeah.
Maybe like B and C.
Parts B and C. Very good. So we've got, we're familiar with the context. There's 50 bowls in the bucket. There's one that's got 100%, two with 50%. Okay. You've drawn the probability distribution. If 500 customers each draw one bowl, what is the probability that more than 10 of these customers will draw the bowl labeled 100%? So firstly, the probability of getting the bowl that is 100% is 1 in 50. There's one bowl that has 100% out of 50 bowls in total. 500 customers are going to draw one bowl. Okay, so the value of n is 500. And we're saying, what's the probability that more than 10 of these customers will draw the probability labeled 100%? So this is a BCD calculation where we're saying x is larger than or equal to 10. So we're saying, what's the probability of 10 people drawing the bowl? What's the probability of 11 people? What's the probability of 12? So it's a BCD calculation. The lower boundary 10, the upper boundary 500. Probability 1 on 50, and the number of try was 500. Okay, so that's how we're going to calculate that one. And then in part C, it's saying, what's going to be better for business? Just offering flat 15% discount on every item, or have this sort of pick a bowl, you know, this sort of novelty event where you get to choose a bowl and see if there's also a 10% discount. See if, which is going to be better for his business. So the probability of getting 100% discount is 1 on 50. The probability of getting 50% discount is 2 on 50, 4 on 50, 8 on 50, and 35 on 50. So this is the probability distribution. Now, if you calculate E of X here, you find it's 16.2. Okay? What does that mean? It means, on average, when customers are playing this game, the average discount they can expect is 16.2%. Okay, so over a day playing this game, he expects customers to get 16.2% discount. All right. Or his other alternative is to offer a blanket 15% discount. So obviously, the more discount he gives is better for the customers. What's going to be better for his business? The blanket 15% discount. Okay. Because he's going to make just that 1.2% more money. I think it's 16.2 from memory.
So that's just timesing all of those
Yeah,
by.
E of X. That times that, that times that. Yep. Very good. Okay. Question 7. Yep. So in question 7, part A says find dy and dx. We've got x e to the minus x, so we're going to use the product rule here. So dy and dx will be, okay. Hence find the integral of, or hence show that the integral of x e to the minus x with regards to dx. Okay, this is what it wants us to find the integral of. Now we know if you differentiate this, this is what you get. Therefore, if you integrate this, then this is what you get. Okay, so we're just, because we've differentiated that, we've got this, therefore if we integrate that, this is what we're going to get. And you will see these questions pop up because it says, you know, part 1, part 2, hence, using what you did in the first part, show that this is true. Okay, now with integration, we know we can split this integral, can't we? We can write it as e to the minus x, take the integral of x e to the minus x, and we're trying to isolate this part by itself. That's what it wants us to get by itself, that part there. So what I'm going to do, I'm going to take that and shove it over this side, and I'm going to take that and shove it over this side. Okay, so if I take it over there, it's going to be positive, which is what we want. We want the integral of x e to the x, e to the negative x. I'm moving that to there. And then this is going to be negative. You get the integral of e to the negative x, and then take away x e to the negative x. So this is just algebra, right? This is the variable we're trying to solve for, and then these are things we're just moving around to get that part by itself. Now, this is where it's helpful as well to write your dx's, okay? Because we're not performing the integral of that whole thing, we're just performing the integral of e to the minus x, which is minus e to the minus x plus c. All right, and that's what it's asking us to show that it equals. Okay, albeit it's arranged a little bit differently. Okay, so I can break this down a bit, right? You can think about this as you've got a take b equals c. Okay. We're trying to solve for b, so I've brung b over this side. Okay, that's what I've did there, move that over here. I've taken c, so we've got a take c equals b. That's the next expression. All right, but we've got this integral here of e to the negative x that we need to perform, so we're just integrating that term. Okay, then we're doing some area estimates for triangles using under estimates and lower estimates. So I might sort of brush over them on the graph, draw 4 rectangles, calculate the overestimate. Okay. Part C, with reference to part A, find the exact area. Let's go to part C, okay? So in there, they're getting you to do some rectangle calculations. You can use your calculator to help you out because they want you to calculate the values to 3 decimal places, okay? So just on the difference between 3 significant figures and 3 decimal places, 3 decimal places means a decimal followed by 3 digits. Okay, so you've got the decimal, you've got 3 digits, and this is the one that you round so that you've got three numbers in your solution. Okay, that's what 3 decimal places means. All right, so we're going to do part C. With reference to part A, find the exact area bounded by the x-axis. Okay, so we have what we got in A part 2. So even if you weren't able to show that it's true, you've still got the equation you can use. And so we've got the integral of x e to the minus x is minus x e to the minus x, take e to the minus x. Okay, plus c, but I'm not so concerned with c because it is a definite integral. Nonetheless, I'll write it up there. Okay, so this part says find the exact area from 1 to 5. Okay, of x e to the minus x. Well, we know if we integrate that this is what it goes to. So that means it's going to be minus x e to the minus x, take e to the minus x, from 1 to 5. I don't need the c, because you're going to have the upper boundary take the lower boundary. The c will cancel. It's a definite integral, so we don't have to see. And then it's just a matter of plugging these numbers in and collecting those like terms. So minus 5 e to the minus 5. Take e to the minus 5. Okay, take. Alright, so this is, we've got minus 5 lots of e, take 1 lot of e. They're like terms because they have the same variable. So that becomes minus 6e to the minus 5. And then we have take negative 2e to the minus 1. And so it's minus 6e to the minus 5 plus 2e to the minus 1. Okay. So I think like that's fine. One way it could be written is it's 2 on e, take 6 on e to the 5. Alright. 2 on top of e, take away 6 on e to the power. Okay, compare your overestimate calculations from part B with comment on the effect of increasing the number of rectangles. Increasing the number of rectangles increases the accuracy of the estimate. Alright. We got time to do 8. And that'll bring us to, in the second half of the lesson, we can spend a bit of time doing some stuff ourselves. So on question 8 here, we've got a probability density function that goes like this. It's a straight line. We're told this is 0a. We don't know the y value, but we do know the x value. And this is 4a. And we're told it is a valid probability distribution. So that means, right, the equation of this line is y equals a. Okay, so you've got 2 ways you could show that you could find the value of a. Firstly, the integral from 0 to 4 of this function a equals 1. Alright? Now a is just a number. We don't know what it is. We don't know whether it's 1, 2, 3. We don't know what it is. But you can solve that. That would be ax from 0 to 4 is 1. And you can go through and solve it that way. I think a much faster way to think about it is that this is a rectangle. And the area of this rectangle has to be 1. Okay? The width here from 0 to 4, that's a length of 4, and the height is a. So you've got 4a is 1, a is a quarter. Right. Either process would generate you the answer, but this is obviously the quickest one. Alright, write an integral expression for the mean. So what's the mean of the probability? I think it's x f of x, isn't it? So does it list it here for us? Yes, it does. So continue right there in the middle. The mean is the integral from 0 to 4 of x times f of x. X times 1 on 4x. Okay, so that is the probability, excuse me, that is the probability distribution function. So we have x times f of x over the boundary. Okay, so that's the integral expression. Anytime it says an expression, it means don't evaluate it. And then in part 2 it says evaluate. Okay, so you can go through and perform that using the fundamental theorem of calculus.
How do you know the area was 1 for it?
So for a valid probability density function, the area under the curve is 1. Yep. Okay. And then calculate the standard deviation. So same deal. I'll look up the formula here. Standard deviation is the integral. So we can just do that one using our calculator. It's the integral. So this is part C. Sorry, part 3. It's the integral of the square root of the integral from 0 to 4 of x, take the mean, that's why you calculated the mean, times the function of x. Like it's a nasty formula, but you can see it just there. Okay, so just putting that in your calculator. All right, let's talk about part B though, because that introduces a sort of a layer of complexity to it. So they say, okay, well, what about we keep those sort of same constraints? We're still going from 0 to 4, but now the function does this, all right? And this is now called b. And it says find the value of b, all right? And again, you could make an integral argument, but it is going to be a little bit more complex. I mean, this is the equation of a line. It has an x-intercept 2. The y-intercept is positive b. Okay, so you could make the argument like that. I'll be going 2 triangles, okay? The area of a triangle is 0.5 times the base times the height. So we have 0.5 times 2 times b. Okay? And we have 2 of them. We've got this triangle here and this triangle here. The same. So that's going to be 2b is 1 and b is half. Alright. So we'll answer. I'll just talk about part C really quickly then, because it's super simple. So show that b is half, that's done. Using information, which distribution would have a larger standard deviation? Okay, think about like normal distribution, right? And obviously the more spread out the data, the bigger the standard deviation is going to be, okay? Look at what this distribution has. It has the maximum probabilities, so the highest probabilities occurring at the far ends of the distribution, okay? Whereas the first one, each event was equal, okay? So what that means is these events way out here, they're going to draw the distribution right out. They're going to draw that probability right out to these events. So the answer is this one has a higher standard deviation because of the events occurring, the events occurring really far from the mode of the distribution. All right, cool. So that's the first booklet. There was a few I skipped over, so if you want to go through them today, let me know. But otherwise, have a nice recess and we'll catch you guys back in here.